So very good morning to all of you. So what we discussed yesterday, and we talk about this all the configuration and the part we have. We talk about the anatomy of yarn as well, right? The flow, how the coordination happened between the client to resource to the node to MR application master. We'll talk about this configuration today. So just give me one. So today this is the configuration we have, and Hadoop-env.sh, right? Yarn env.sh setting for Hadoop daemons for process environments. Core hyphen. I believe you might be familiar with this core SDFS map rate slash Hadoop environment. The new entry is what your yarn site.xml, where we configure the yarn components. That is resource manager and the node manager. Okay. So setting for dev Hadoop daemons process environment, configuration setting for Hadoop core such as IO settings that common to both SDFS and YARN. Okay. SDFS configuration for SDFS daemons, name node, data nodes, YARN site.xml, you have resource manager, node manager, mapper site.xml, map responsive application, many more. Slaves for nodes, for data node. If you are having a node manager, and data node, that running on data node and node manager, so that comes in the slips category. So this all we so this is what we have, the property, which in one point text is data dfs.data.dir. We will define the data node path to store the data and to LFS. And in new property we have what, dfs.datanode.data.dir. Okay. DFS HTTP address. So these are the new property, guys. Okay, we have to just keep in mind the changes we have. fs.default.name. Anyone answer? fs.default.name. This property belongs to above. I believe you have given too much time onto your cluster designing. Too many queries we had. So you have set this. Yes, this is all the configuration we have, same as DFS side XML map rate, dfs.mapper.site. Right, this is the configuration. It just changed, it just a new property with the new version of cdh4 cdh5. The changes, the objective will remain same. There's some changes are there which we have for the name node, right? Slaves for data node, core side xml, there's xml file fs.default.name, right? We put the data node, name node, so fs.default.fs. This is the changes we have. Okay, so these are the deprecated properties we have into 2.x. Okay, even it support the one this property as well in cdh4, but make sure in cdh5 it's not going to work. Okay, so you can either use the aileron new property, but in cdh4, but cdh4 required this. Okay, I believe it is familiar, right? env.sh offers a way to provide custom parameters for each of the servers. Hadoop daemons, right? So example of environment yarn. So nodes daemon size you can set it here. Data node size when it takes to storage, how much storage, how much size, heap size you define when you will allocate the storage for the node to run the data nodes on your cluster. Yarn for the, this is for the yarn daemons. Okay, so the particular column we have. and next. So it's not be more new for you. I believe you guys are familiar with the previous configuration files. It's new entry for the yarn site at XML. It is the core measure. This is what all your core, SDFS, yarn, this all comes into the metrics like core, SDFS, yarn. This all called the metrics, guys, right? So any property which a property which file it belongs to. Yesterday we have seen multiple files configuration, right? So that comes under that. Okay. I guess Shivani is here now. So hi Shivani, good morning. Okay. XML version, SDF side XML, how you're writing the property value. So I believe we have discussed this all the part, and it's the same configuration. The deprecation you can see the property name is changed. fs.default.fs is fs.application same and same. So you can put the value. Okay. So set this property, something more extra property. You can see the new one, job history. So when you go for the daemons, remember when you write the JPS for the yarn, you say the job history will be ready. Okay. I'm after the dot job history dot address. This new one, yarn dot resource manager dot address. Okay. So you can take the reference of links which is mentioned. It is almost every file is quite similar. The terminology is just changed into in terms of task tracker. You have to see it's a node manager server, right? That's the only difference, but the files will remain same. So quick view. I guess it's a previous one. There's some couple of changes has been done into Facebook cluster. I guess not been updated here. Okay, so cluster Facebook which they were using and the size, there were two measure cluster, 1100 machine cluster with 8800 cores. I believe we have discussed this cores and things into the benchmarking time. Hope you remember, right? And about 12 petabyte raw storage, 300 machine cluster. Now it has been increased actually, guys. Okay, so the previous one. So anyways, this is what the cluster, two measure cluster they were using and you have to so use Hadoop to store copies of internal logs and dimension data source and use it as a source of reporting, analytics, and machine learning. This is what the data they were storing. They're using for that reporting. Reporting we have will like discuss about when we talk about the Hive. I show you that FB Insight what the reporting using Hive using the reporting tool analytics and the machine learning to make a model to design the pattern to target their customer. Okay. So this is the community configuration in production that Facebook is using. Community nodes has 8 cores and 12 terabyte of storage each community node. Okay, this is a higher standard. Generally, we are having a 1 to 2 terabyte of standard node size, but this is how Facebook is using the nodes. Okay, Fuse is another product of Facebook, but never find any product using the Fuse. Okay, Hive you can see. So we are heavy user for both streaming as well as that's what Facebook Java API. We have built a high level data warehouse using this feature called Hive. So Hive is what data warehouse and we already discussed. We have also developed Fuse implementation over SDFS. It's product of Facebook. Okay, and okay. This is the name node, and you can see that name node is more a memory hunger, right? So 64 GB of RAM. Hard disk is less is fine. Processor at Ethernet and operating system. Second in name node is almost the replica, you can see. Instead of 64, you can put a 32 GB. Data node more into disk space. Okay, less into RAM. So higher configuration in terms of disk data node. Name node require more RAM, memory hunger. Hope you understand why it is called memory hunger. So a typical 1.x, if it is in the cluster with the second in name node, you can do, and it will choose support for the 2.x, no problem. So small cluster you can design in this way. You have I believe you have option to increase the size of the cluster if you're working on a small POC or a kind of small cluster as per the data size is increasing. You can commission, you can add a new node in the cluster and you can work on that. Okay, so single node, small cluster, two node cluster, and larger cluster. So this all depends on your requirement. You've got to work into this. Cluster size. So slave hardware, what you have to talk about, keep in mind storage and computation. Master hardware, what you have to talk about, RAM, we have to bit more modest but dedicated, almost identical to name resource manager. So these are the resources and hardware you have to know. You should focus according to the categories and to the master and slave. Okay. Memory hungry memory requirement can grow independent on the cluster size. Cluster sizing and would consider requirement of addition components such as express. Okay. Operating system Java, operating system SSH configuration. Cloudera is enterprise level we are using. Apache Hadoop we have seen as well how to work on. Hortonworks HTTP is another enterprise level we work. Mapper is good for the Spark environment. It's Amazon Elastic EC2. This is also a good option to work with that. Okay. So this is all what we have, and it's a question time. Right. So this part we cover uh, for Jan, and I believe this talk we have the installation have been shared. In case not, we'll get it by today. So we'll ask to go for this installation and try this cluster on your machine. All right. I guess we had discussed this yesterday before as well. So a quick look. You have to configure all this 5 daemons of or 3 SDFS components and the yarn components. So slightly changes are there in terms of directory, in terms of starting the cluster. Rest of things will remain same guys. Okay. Some extra property I have added into this. This is yarn preparation, and that is extra property for the name node to store the metadata on the disk you have to define, and for the data node as well, you have to define the path where you want to put the data node data on LFS. ETC host, right? I believe all you have gone through the Apache cluster previously, and this is how you're starting all the daemons one by one, and it's all coming. Okay, so this is all about for yarn. Alright, so this is what your data acquisition phase means, migrating data from RDMS and putting data to Hadoop. In production it is named as data acquisition. That's right. This is the user. Look what exactly you have. User are feeding the data into your database Oracle. Okay, this is the upstream we have. Using apps and banking apps, and they're sharing the data with your database. Now what they're doing, they're facing the scalability issue, so they're migrating data from RDS to Hadoop. Okay, and then the data is onto Hadoop is in the physical format. They move into the Hive into the logical format. We'll see that as well. We have already done this on the practical. Okay, so moving data from RDS to Hadoop. So our DBS is called what? Downstream. Downstream source what we have? Data storage is your Oracle database. Okay. Now, so this is a scoop. So how the connectivity happens, you might be noticed whenever you put the you run the scoop command, you're facing some kind of issue, skill, your connectivity issue, database connectivity loss. So what exactly, why this exception occurs, and what is the solution we have for this? So this is what we have. First, when you migrate data from RDS to Hadoop, first connectivity required was JDBC. Right, remember that scoop import, JDBC, MySQL, Oracle, whatever you're writing on this. So first connectivity must be established, so communication should be established. Your application should run to this to this. Okay. Then second phase, pull the metadata. First, it moved the metadata from Oracle, pass this metadata into Edge node. A new terminology Edge node we have can refer to the same. Then it passed physical data, then it migrate data from data, the physical data to that inform that storage. This is how it happens. Okay. Now, communication established. We are moving data from RDS and putting data to HDFS. The first phase, JDBC connectivity is done between these two. Okay, storage. Next, we require many cryptography algorithm. Data should be secure while migrating data from RDS to Hadoop. So, and it should be compressed. So we are using multiple mechanism. So cryptography, which is very basic SHA algorithm, secured hash algorithm. For security purpose, we use SHA to transfer the data in terms of packet between the Oracle to HDFS. Okay, and this is what data acquisition phase, migrating data to one DB to another DB. So in production, they may ask what is this. So what you're doing, data migration is called technically this one. Then data validation is required. Data validation is nothing to check special character null value, because in RDBMS we have a different kind of what you can say schema and all. We have a limited schema into this Hadoop. So any null value or a duplicate record, it should not be inserted into your another database. So we will check this as well. So how we perform the data validation, we'll see. We have a different mechanism for that. So to check special character null value, they write special script to reference this data in HDFS. So see here, circuit key. How to avoid the duplicacy? So duplicate record should not be inserted. Okay. Let's say you have 3 record. There is a table, and you're moving this data to RDS to other. Okay. So 1 record, 2 record. You can see that this record is repeated. Okay. So for every record, it creates unique identifier while pulling the data from scoop. Got it? It will define a unique identifier. Correct? Now, it has different mapping rules. It has different mapping rules. Like I will give a quick overview to define the unique identifier, how they write the scripting and all. They use the scalding, which is a very unique concept. Other companies, depends upon the company's requirement, there is scripting the way you're using. Scalding is very new and it's more secure. Scalding is the concept. It's a combination of scalding and scalar. Okay. So how to define the unique identifier for every record to avoid the duplicacy. If they're writing some kind of algorithm mapping case by using this mechanism, some kind of terminology you can see here, references K, alert key, columns, and all things. Okay. Later, they are using changing data capture (CDC) to find out duplicate keys. Now, If we pass the duplicate keys, how circuit keys, which we are talking about, circuit, this is how it will identify, say, input you pass 500 records, output you will get 498 records. No data is deleted, duplicate is what? That will show into error track. Okay, into that you can check it easily. These two records are duplicate and they filter out. Okay, this is how you avoid the duplicate data. And once data encryption, you know the encryption decryption, very simple. When you send the data, it's encrypted and then you duplicate. So convert the hash value into dimension value. Finally, you insert data into Hive external table once data stored onto your HDFS. So these are the multiple phase we have. We have just seen one part on how to migrate data from RDS to Hadoop and moving to that. But these are the multiple phase happens internally, and for security point of view, you're writing some kind of activities, encryption, data validation. You will ask if you do the data validations which using the circuit key to avoid duplicacy. They simply ask you this question, and you have to very much clear with this all the concepts. Okay, data validation, it has different CTC and all. Okay, okay. So this is something the project flow of finance and how they migrate data and what are the different streams we have used. You can take a look. The upstream source, Oracle, right? Right. This is what your objective. Taking data from some source. Data is coming from upstream, putting onto Oracle, then moving to the SDFS. Okay. This is how the data validation. Just now we talked about the circuit key. Right. There's a quick flow. Changing data capture, validation. So slowly changing dimension, encryption to decryption. That's what we have discussed. And then after that, publish phase and front end, how what all once data is coming and putting onto changing the dimension. At front end, you'll use business users and what tool you're using. That's called here at the front end in production. You're showing this. Okay. So quick overview, finance view overview, what we have. So this is a complete story. Okay. Right. So this is all about the data acquisition phase. We migrating data from RTMS to Hadoop, and these are the multiple stage we have to move the data to SDFS. All right. Okay, come back. Okay, so I make you understand what this flow is all about. Like, if any user has to purchase anything online, let's say a mobile phone online, has to visit multiple websites, Amazon, Facebook, oh sorry, Flipkart, Snapdeal, eBay, and many 4 to 5 websites to find out where's the best deal is with the same price of okay, or the best product I can purchase in the this price. So these are the different APIs we are using. Okay, these are the different websites we have. Okay, so what ultimately it kill your time as well. E-commerce agenda to save your time and money. But now we have multiple option even we are taking time. It's sometimes take 30 minutes. It takes time, right? To if you're targeting multiple web platform to get the best deal. So what here this flow say, using the apps and say that I'm having a different API, right? Like Twitter, we it was a open source API, so we taken the data. So this is a 1, 2, 3, 4. We have a different API. We will purchase the API of the different website, Flipkart, Amazon, XYZ e-commerce, and I'm purchasing the API of that. That's of course the commercial API, and then start streaming. Then start pulling the data. Like just now we have done using Twitter, okay, and putting it onto your database. This is nothing your Hadoop HDFS, right? Now I will write some business logic. There's some data tuning required, data modeling required. Okay. Put the data into that format, so developer can write in that. You can give the data to the developer into that format, so they design the code. Now here is your business logic. Batch wise near real time depends upon all requirement, right? And this is your machine learning model which you will write at multiple pattern. This pattern will help to decide the customer which is the best deal available for your range of your for your product. So this is the front end recommendation. You're using data in your data visualization tool. So you will give this apps front end. User will select the categories into that electronics that we have mobile categories. Into mobile, you fix your range of price, 5,000, 10,000. What the features. Okay. Like in Amazon, I believe the filtration, multiple filtration part is there, right? And in which city you are looking for. So there's all the information based on that which matches with the best pattern. It will retrieve the data and will send it to you. Okay, it will give you the top best temp range of product which you have asked. Okay, some of the use case we have. User will be able to see top 10 items with sample friendly. He can use see more if he wants to set up the item. User will have some. So these are the business case which you can design, which can create your own, and you can start writing using your tool which you have here, like the POC which we are giving based on that. So you can have a hands-on and you can idea to write the use cases on that as well. That was the agenda to give you the projects. Okay. So now these are the modules we have used for this product. Data ingestion, we have multiple APIs we have seen, and data sources. Data storage we are using HDFS, HBase. Processing Spark, Pig, Hive. For analysis purposes, Python, Scala, Spark, machine learning. Okay, as well. Data visualization we are using any web mobile application. at all. It can change as well. This is what we design. If you find some other suitable tool, you can work to fulfill the objective. Okay. For this project, we are using this one, and this is our architecture we have. Okay. So, like very parallel to like in real time, you can see some Travago, but it is for a particular hotel. You can take a look of stumble upon a giant page. You can get the best pages are available. So these are the flavor you can have, and you can work on. Okay, so you have a business model here, and what you learn, you have a Twitter. You can pull the data and putting onto your Hadoop, and or any streaming you can use that. Not mandatory, and you can put the data onto this, and you can then start processing. You can write your own use cases. Depends which part you are confident that is into big or into high. Okay, and then start writing the use cases, make some data sets, and try from your end. As we are sharing our own data sets as well, but you can make your own some data sets and see how effective business model you can prepare and use case you are ready to work on. Code optimization, that is very important point. Okay, and you see your roles and responsibility as well. You're doing the R&D, so you try it for everything. Okay, almost you have done in a small part. Now you combine this all and make a small uh, POC on which you can see, yes, this is how we are trying to work and handling some kind of data which is quite useful, which is really helpful to take the business decision. So for that, how the pattern you're writing, that depends your logic and the use case and the pattern. If you have any understanding of machine learning, if you try onto this, or else you can go with the big and high, which I believe you're good enough to work. Okay, clear case. Yes, can I get a quick response? Questions? Thank you, Baba. Okay, the topic which we are left, that was pending was HBase bulk. We'll cover in just another 10 minutes. Okay, so we have a file. Okay, cat my file, I guess. So let's say this is the bulk data. I have to move into HBase. Okay, it's a tab delimited. Okay, this data I will move on to your first you will move the data to HDFS, and then HDFS you will move the data to HBase. We'll see what the process we have. So I've shared the docs. HBase bulk command. See here. First of all, you will create a table, right? First name, last name. You see here. This is the first name, guys, and this column is what? Last name. This is the two column I have taken as a columnar family into my HBase. Hope you remember, right? And create a file with employee first name and last name in Cloudera desktop, which I have already taken. That's file name. Copy this data onto your HDFS. You know you how to store data in that one. Now that is what. Now you have to move the data from SDFS to HBase, HBase where into this table which you have created, right? And this is what you're writing. That simple. HBase is a complete API. Okay. Hyphen D, there's no space. Import tsv dot columns HBase row column key row key is its first name. What is the column you have? First name, right? And last name, right? And the table name, what do you have? Employee table. Employee. Okay. And you will give the path of the file you want to move from HDFS. So this is the path, root directory, whatever the path you are given, and root directory, what is the file name you have stored? That is called what? My file. I have not mentioned here. So what is the file you have taken? You have to define here my file. Okay, and then it start moving the data to RDS, and it's a complete streaming will a MapReduce program will run, execute, and you can go and check your scan table, table name employee table, and see the result of it. Okay, this is how we. It's a quick discussion on to HBase bulk data. Okay, I believe you have this docs with you already. Abba, we do not define the columns. Okay, you try this and you see that you will understand what is the columnar family, what is the row ID, and what is the column name here. Data type is not into your HBase. Right, Abba? Yes. Quick response. Thank you. Uh, this docs is already shared with you. I guess that day, short of time, so could not cover. So this is the part, the bulk data, how we read and how to go. Okay. Thank you. Yes, anyone? Anyone tried this? I guess no one. Okay. So try this. I believe what are the remaining topic which we have, and almost we have done. And the topic which we have, the zookeeper, will continue by tomorrow. I guess it's one day. It's more than enough. It's a small topic. Someone raised the hand. Benefit of using columnar family is grouping of data. Yes, you can. Every column, it's all the row ID. It's all the using for the filtering purpose. Right, above. It's all for the filtering purpose we are using. Okay, good question. Okay, guys. I guess done. See you then tomorrow. Okay. Sharp by 10. I guess someone raised the hands. Who? Yes. Um, okay. Thanks for you. See you then in next session.